Welcome to The Explainer. All right, today we are diving ahead first into what is, let's be honest, one of the trickiest parts of running things in the cloud, figuring out what's wrong with your network in Kubernetes.
You know, back in the day, an IP address was like a physical street address. It didn't change much. But in Kubernetes, it's a whole different ballgame. IP addresses are constantly changing. The whole network map is fluid. It's a dynamic beast. And that means our old ways of troubleshooting just won't cut it. We need a new game plan. So, let's get into it.
So, here's the plan. First, we'll get a handle on why this is so complex. Then, we'll lay out a framework, a sort of map for this maze. We'll load up our toolkit, tackle some real-world problems, and then zoom out to see how we can visualize the whole thing. So, why is this so hard? I mean, a simple connection refused error can kick off a wild goose chase. Is it the CNI? Is it DNS acting up again? Is it a firewall rule somewhere? See, without a clear strategy, you're just lost in this massive interconnected maze.
And to get through that maze, you absolutely need a map. Just wandering around and trying things randomly? That's not going to work. What you need is a systematic approach. And for us, that means thinking in layers. It's the only way to methodically pinpoint where something's broken, and trust me, it'll save you a ton of time.
Okay, and this right here, this is the mental model for everything we're about to do. Think of it like a ladder. We start at the bottom with the basic pod-to-pod stuff, and then we work our way up, layer by layer, through services, policies, and finally DNS. This structured climb is the key to figuring out what's really going on.
All right, you've got your map, but you can't go on this journey without the right tools. The tricky part is that modern containers are often built to be super minimal for security. We're talking no shell, no ping, no anything. So the real skill is knowing how to bring your tools with you right to where the problem is.
And your number one go-to tool for this should absolutely be netshoot. Seriously, this thing is a lifesaver. It's basically a Swiss Army knife for network troubleshooting, all packed into a single container. You can pop it into any environment, even those super locked-down, distroless images that have nothing in them.
And here's the magic of how you use it. With a simple kubectl debug command, you can literally attach this netshoot container to a running pod. This lets you peek inside its private network world. Or even cooler, you can attach it directly to a node to check out the host's network setup. It's just so incredibly powerful.
Okay, before you even type a command, stop and listen to what the error message is telling you. A connection refused is actually good news. It means your packet made it to the destination. You found the right house, you just knocked on a door where nobody answered. Maybe the process isn't listening on that port. But a connection timed out? That's a whole other story. Your message got lost somewhere along the way. It never even arrived. That's your clue to start looking at firewalls, network policies, or routing.
Okay, enough theory, let's get our hands dirty. We're going to take that 4-layer framework and our toolkit and apply them to some of the classic problems you're definitely going to run into.
All right, here it is. The number one problem. I can't reach my service. Your app tries to hit a service, and nothing. Now, your first instinct might be to fire up tcpdump, but hold on. The real first step is way simpler. We need to ask, does the service even have a destination to send the traffic to?
And to answer that question, this is the very first command you run. Kubectl get endpoints for your service. The beautiful thing about this is that it doesn't touch the network at all. It goes straight to the Kubernetes control plane and asks, hey, which pods are supposed to be part of this service? This is your ground truth. Now, if that command comes back empty, congratulations, you just saved yourself hours of chasing ghosts. Why? Because it means this isn't a network problem. It's a configuration problem. Maybe your pod labels don't match the service selector, or maybe your pods are just unhealthy and failing their readiness probes. So remember, always check your endpoints first.
Okay, let's talk about a really sneaky one. This one will drive you absolutely bonkers. Everything seems fine, but every so often you get these random DNS failures, and they always last for exactly 5 seconds. It feels like a weird network hiccup, right? Nope. It's a classic configuration trap.
And the culprit is this little number, 5. See, by default, Kubernetes sets up every pod's DNS config with a setting called n.5. What that means is, if you look up a name with less than 5 dots in it, like say, my API service, the resolver will first try adding a bunch of search domains to the end of it. So one simple query can turn into 5 or 6 queries, and that can totally hammer your DNS server.
And the fix is so simple, but so important for performance. Just use fully qualified domain names and, this is the key,
Add a dot at the end. That final dot tells the resolver, hey, this is the exact complete name. Don't go searching for anything else. It completely bypasses that whole enddots mechanism, and your timeouts just disappear.
Right, on to maybe the most frustrating problem of all, the silent drop. Your connection just hangs, and then it times out. You don't get refused, you just get nothing. Crickets. When this happens in Kubernetes, your number one suspect should always be a network policy.
So instead of just guessing which policy is the problem, you can actually ask the network itself. If you're running a CNI like Cilium, a tool like Hubble is an absolute game changer. You can literally just run Hubble observe -verdict drop, and it will give you a live feed of every single packet that's being dropped. And this is the best part, it tells you exactly which policy is doing the dropping.
Here's another one that'll trip you up. You can ping a service, and it works perfectly. Pings are coming back, everything looks great. But then you try to connect your actual application, which sends bigger packets, like for a TLS handshake, and the connection just hangs. It never completes. What in the world is going on?
Well, this has all the classic signs of an MTU mismatch. MTU stands for Maximum Transmission Unit. Basically, the overlay network in Kubernetes adds its own headers to your packets, which makes them bigger. If they get too big for the underlying physical network to handle, they just get dropped, silently. The way you can prove this is with special kind of ping, one that sends a big packet and tells the network, do not fragment. If that ping fails, you've found your MTU problem.
You know, command line tools are amazing for deep dive forensics on a single connection. But sometimes you need to step back. You need to zoom out and see the entire forest, not just one tree, to really understand what's happening across your whole cluster.
And that is exactly where visualization tools come in. Things like Hubble or WeaveScope are incredible. They take all that raw data and turn it into a living, breathing map of your cluster's network. You can actually see which services are talking to which, trace the flow of traffic, and spot problems instantly, like a dropped connection showing up as a big red line. It's fantastic.
So when you boil it all down, getting good at Kubernetes networking isn't just about memorizing a bunch of commands. It's about having a system. It's about combining that layered, methodical approach with the right set of modern tools. That's what lets you go from looking at a single packet all the way up to understanding the health of the entire system. So the next time something breaks and everyone's looking at you, is it going to be a complete mystery, or is it just going to be a series of questions that you now know exactly how to answer? With this framework and these tools, you're ready to solve that puzzle. Thanks for watching.